video first. This is not real long, but it's probably going to seem like it's long to some of you. But be patient, try to watch it as much as you can. What this video is all about is what we're going to be talking about to some extent this morning. And so these animations of these particular kind of processes within the cell are super interesting to me, and I trust that they'll be super interesting to you. And if nothing else, they'll give you some kind of idea of the kind of complexity and the kind of astonishing wonders that we see at work in the middle of the cell. What was going on in that video was just an animation, an animated depiction of a variety of processes that go on inside of the nucleus of every cell in your body with DNA. It's used in a variety of ways within your cell, and those things were attempted to be replicated and illustrated and demonstrated in the particular video. Hopefully you found that was somewhat helpful. Today we're going to deal with apologetic question number 2. I decided that we're going to do this in 3 weeks rather than 2. I just didn't know how to jam everything into the rest of everything into a sermon today. So today we'll talk about this question, and next week we'll talk about logic and mathematics. Today we're talking about the DNA code, the information of the DNA code. We're going to look at a text here from the scriptures. This is found in the 139th Psalm. I'll start reading to you from verse number 13. Psalm 139, verse number 13. This is what it says there in the New International Version of the Bible. For you created my inmost being. You knit me together in my mother's womb. I praise you because I am fearfully and wonderfully made. Your works are wonderful, I know that full well. My frame was not hidden from you when I was made in the secret place. When I was woven together in the depths of the earth, your eyes saw my unformed body. All the days ordained for me were written in your book before one of them came to be. Now, this particular passage, in talking about things, I love the phrase that it uses there, that I was knit together in my mother's womb. I don't know about what you saw in that video, but didn't that kind of look like somebody was knitting with invisible needles? Yeah. That's kind of what it looked like to me, and I thought that it was a very nice way to bring together some of the thoughts from this particular passage of Scripture, and as they might apply to the aspect of scientific endeavor that we'll be talking about today. We are going to be talking about the information in the DNA code. If you recall last week in some of the introductory comments that I was making, I said that this is one of the areas that I think is really dense and really powerful as far as apologetic arguments. The area of the code that's in DNA is something that I think very clearly and very powerfully points to the existence of God as a creator. And in fact, to me, it's of such a wondrous nature, I can't hardly believe that anyone can look at it and not see the fingerprints of God all over it. Hopefully, we'll see the fingerprints of God all over it today. Now, when we talk about the DNA code, what are we talking about? Well, let's look at the details of it. The DNA code has an alphabet. You saw the little letters going by there in those base pairs, A, T, C, G. I won't even tell you what all those stand for, but they are basically nucleotides, little pieces of amino acids, if you will. And these are the 4 different items that are used by your DNA code to encode all the information that it does encode. So you saw that it said there are some 3 billion base pairs in a standard strand of human DNA. That's a lot of letters, is it not? Each one of them represent one of these letters, and there's only 4, and they get repeated over and over again as often as they need to express whatever it is that they are meant to express. But this is the alphabet of the DNA code these compounds, these 4 different compounds that make up basically the spine of your DNA chain. Now, there are words in this code as well. That's the letters, or the alphabet, the letters, that same thing, the A, T, C, and G. But there are words that are called codons. Now, what a codon is, it's basically 3 of those things in a row. And every 3 of those base pairs that are put together down the length and depth of your DNA code, each one of them represents a word, if you will. Is it really a word? I mean, how many words can you make out of A, T, C, and G? Not that many. But in DNA speak, there are as many combinations of those 4 letters, that would be 4 to the 4th, possible combinations for words that could be making up that particular language of the DNA code. And so we have letters, we have alphabet, and we also have words. We also have sentences. All right, sentences. Those words, those codons, each one of them represents an amino acid. So there are 20 different amino acids that are used, for instance, in human life. Most life that's true for. But there are 20 different amino acids that are used to make all of the proteins and all of the enzymes, all the biochemicals in our body. Just 20 different little amino acid residues or little molecules that are amino acids. There are 20 of them, and of those 20, your body is instructed by your DNA code to put those together. Those are the words. Your body is instructed to put those together in certain ways, and the sentences become proteins and enzymes and various other kinds of biochemical agents that are manufactured by your cells. Just about everything is either a protein or an enzyme. There's a few other little things as well. But each one of those letters goes into making a word, an amino acid, and those amino acids, by your DNA code, are put into sentences, which in all, according to this particular illustration, make up things like proteins and enzymes and other biochemicals. Are you with me still?
Yes.
All right. I look at this stuff and it starts making my noggin, rattle. I think hopefully I won't make yours trying to relate this stuff to you. But that's your DNA code. Now, if that sounds like that's quite complex, it is. You saw in this video a depiction of the kind of mechanisms that have to go on inside of your cell to use it. If you found that video amazing, it shouldn't be all that amazing, because however many trillions of cells you have in your body, they're all doing that. All doing that with a kind of speed and even more than what we saw depicted in the video. And so, it's really, it seems quite amazing when you look at it in detail, but when you realize how common it is, it doesn't seem all that amazing maybe, not only in your body, but in the body of your dog or your cat, if you have a gerbil or a hamster, right? Anything that's alive, even plants, for goodness sake, and bacteria, they all have these same kind of things going on within their nucleus, all using DNA codes, all using the letters, the codons, or the words, and proteins and enzymes, or the sentences. They're all using the same kind of code. The code is not the same in every person, in every being, in every species. That's not the same, but the system is the same. That DNA is used, and that DNA is used in the way that we saw depicted in this video, that's the same. That this kind of code that I've been elucidating for you, this is the same. It's really the heart and soul of what makes for life. Now, when you look at something like this, it's a wondrous thing. And I think for people that are leaning toward faith or that are in faith, this certainly is not anything that doesn't just make your heart filled with praise for God. And you look at something like this and you think, wow, is God smart? Is God wondrous? Is God amazing? Is God wise? And all the other things that we can say about God. But if you're not disposed toward faith, then you look at all of this and, you have to come up with some kind of an explanation for it. Now, we know that when we're dealing with non-believing scientists, their number one approach to everything that has happened is basically chance. I mean, it all comes down to that, whether we're talking about the universe itself or whether we're talking about living things. If you don't have God in the picture, if there's not something purposely creating what is, then you are left with basically one other alternative. If it's not God, then it has to be chance. Stuff was, and this just happened to be the way it unfolded. No rhyme, no reason necessarily. It's just, this is the way that it came, unguided and unprodded. That takes a lot of faith. When you see something like that video, what takes more faith? Believing in God or believing that something like that came out of nothing, came to the place where eventually it produced all the wonders and everything else that we see in life on planet Earth? That actually, it seems to me, takes a great deal more faith than probably any of us could ever brag about. When I think about atheist evolutionists in particular, I think probably we don't need to look down on them. We probably need to go ask them, how in the world did you get that much faith? Whatever it was, let me know so I can get that much faith in God. But anyhow, what's the basic point that I'm trying to make right now is just this, is that if you don't have God in the picture, then you have to go with chance. And when you're dealing with chance when it comes to biology, basically you're saying that things happen just because things happen to be near each other. Things happen just because they're reactive toward each other. One thing led to another, and out of that reality, trial and error through many chances and many opportunities produces something that is more and more complicated, more and more detailed, more and more information in it. And really, what it comes down to is the governing principle for all of that has to be self-organization. So if you don't believe in God, but you believe in chance, and you're believing that all of this complexity that we see in ourselves and in life here on planet Earth around us, if you look at all of that complexity, if you don't believe in God, you have to believe that somehow or another, stuff, as it came to be, is self-organizing. We mentioned just in passing a little bit last week about self-organization principles in regard to the cosmos. Those principles fail. I mean, they just don't really explain anything. They're nothing really but a shield to keep people from dealing with the possibility of God. When it comes to biology, self-organization, I think, is demonstrably false. It's something that can actually be proven not to exist. That's particularly true in the DNA code. You have to ask yourself, if I don't believe in God, I believe in, therefore, chance and self-organizing, you have to ask yourself, what's the natural process look like? How did this happen naturally, if it did? Well, you run into some problems when it comes to DNA. Because in talking about the sentences that DNA writes, the words that DNA has in its information core, the letters that make up those words in those sentences, you have to be able to come up with some kind of a biomechanical basis that those things would self-organize, that they would be produced by chance, and you run into problems with that. One of the problems that you run into is that if you're dealing with chance and self-organization, there's not a template that you're running off of. You don't have a blueprint, you don't have a plan. Things are just thrown together, And out of them eventually comes what you are purporting comes out, which is, the living. Here's the problem when it comes to DNA. DNA is not susceptible to any biochemical, biomechanical basis for self-organization. You see those 4 letters that we are talking about, the C, the A, the T, and the G, those base pairs that make up the heart and soul of the information holding properties of DNA. Those things, because they are bonded by just hydrogen bonds in the middle of the DNA code, that's where all of the business happens inside of the cell. All that you saw, splitting apart the double helix in the video, all the work that was being done, all of that work is getting done in the middle. You got the double helix, and then you got these like little ladder rung-like things going across. Those are 2 base pairs that are joined together by hydrogen bond. So it's not valence bond, or covalent bonding. So it's not it's not what you would say a strong chemical bond. It's something that's really held together. I guess in the scheme of things, we could say relatively loosely. And the reality of how each one of those base, the C, A, T, and G, those base elements, connect in the hydrogen bond aspect of them, is that there is no differentiation, there is no ability or no determination on the basis of the chemical itself what it should be connected to. Now, that's probably very confusing. Let me see if I can run that by again and make it a little more clear. You have those elements, the C, A, T, and G, that make up those base pairs. They have a hydrolyzed end to them. That's the business end of them. That's the end where all the action happens as far as all that machinery we saw in the cell, all the gene reading, all of the gene replication, all of those kinds of things happen on that business end of that molecule. The problem that that molecule presents for self-organization and being developed by chance is that part of the molecule is totally undifferentiated as to what it prefers. So there is nothing in that side of the thing that keeps one amino acid residue from hooking to another. Now I said there's C, A, T, and G, and we mentioned that there's 20 amino acids, so there's actually 20, and there's a couple more amino acids, but that's the ones that are used in human life in particular. Any of those 20 are just as likely to bond at that site as any other. So even though you have certain connections that are always so, you always have C connected to the same molecule, always have T connected to the same molecule, G to the same molecule, and C, T, G, and A, they all get connected always to the same pair partner in DNA. But chemically, there's no reason for it. There's no reason for it because that hydrolyzed portion that is the business end doesn't care what it's connected to. It doesn't pick one over the other. It doesn't have any affinity, more one to any other. So if you are dealing with, and experiments have been done by non-believing scientists, right? Experiments have been done to try to understand what happens when you put that reality of chemicals together, what comes out. And what comes out is that you have a mishmash of all kinds of supposedly biochemical chemicals, but none of them are useful. They don't express information. They are unreadable. They don't produce anything. They can't be replicated by the mechanisms within the cell. And so you get nothing. In other words, if you leave it to chance, if you leave it to self-organization, do you get information in a code? No, you just get randomized chemical connections that don't do anything. Now, that's a really strong point. I hopefully am communicating it to you clearly enough for you to see that. But that's a very strong point. What it means is that when we say that if you don't believe in God, you have to come up with some kind of explanation for this information content in DNA, there's no place for you to go. You can't go to random chance because the chemical properties that exist in these molecules don't leave that as an option. If you were relying on random chance to produce those things, it would have never produced those things. There's too many options. When you start taking the odds of amino acid residues connecting to other amino acid residues, you're getting, because there's 20 of them, you're getting your odds raised to the 20th power. So you're talking about an incredible number of possibilities that you would have to go through in the possibility space, in the probability space, to try to come up with even one molecule that was useful, that did anything, that could be, that could develop cells, that could develop amino acids, or proteins and enzymes as cells use them. It just isn't going to happen. And so when we talk about the information in the DNA code, we are talking about something that is incredibly complex, incredibly effective, incredibly well used, demonstrated in its effectiveness, being well used. Every cell in your body, every cell in everybody else's body, every cell in all the things that are alive. I mean, this particular approach to things has demonstrated itself over and over and over, and I mean, so many times we couldn't number them all. This particular, I can't call it technology, but at the same point in time, doesn't it have something in common with technology? If you saw technology that complex, that useful, that effective, what would you think about that technology? Would you think that, wow, whatever tornado just happened to go through and throw all of those pieces together into this thing that is doing that, well, that was one incredible, fortunate tornado? You wouldn't think that. I mean, even thinking just about me saying it up here from the pulpit, right? You think, that's the stupidest thing, Pastor, I've ever heard. Well, exactly. It is the stupidest thing you've ever heard, right? To believe that something that is so specific as far as what it has to be to bear information, for something to be so wise in how it was put together, in the way in which it works, over and over again, demonstrated in, well, I mean, in the time that we've sat here. Think of how many millions and millions of times it's been demonstrated in things that we're not even aware that are going on inside of us. Where did that come from? Well, you can say it came from chance. You can say, it came from self-organization. But you're on really shaky ground on either of those bases. Chance, the numbers don't add up. The possibility space is too large to ever run through enough iterations to happen to chance upon something that works, right? There's just way too many possibilities and very few that would actually work. Is that going to produce even one cell that's alive, let alone all of this life that we have and all of its wondrous glory on earth? Would it develop any of that? Well, I think that beggars the imagination. Again, what do I say about this? Believing that requires more faith than what we believe in. I mean, we have eyewitness testimony that a guy came out of the tomb, and that's an outrageous story. But we have eyewitness testimony. No one's been able to undermine it or to undo it. And the fact of the matter is, today, when you believe in it, God comes into your life. The Holy Spirit takes up residence in you. Right? We have great reasons to believe in God the Creator, and you have basically, if you're not a believer in God, no good reasons to believe in self-organization or random chance. So where does that leave us with the information code and whatnot that we have inside of cells? Well, it just makes life, I think, for an atheist very difficult, but it's not over. I said last week that discoveries over the last few years in particular have, in my mind, completely and inexorably undermined Darwinism to the place where it's not viable. Now, I know that a lot of you are taught, and I think in a lot of freshman biology classes in universities today, it's still taught that Darwin is the gold standard. That Darwinism is the one truth that unites all science. Well, it hasn't held up to the discoveries that have been made since it. Now, Darwin published The Origin of the Species in 1859. His work that went into developing was going on 20 years or so before that. After Darwin, in 1859, there was a basic scientific revolution as more and more scientists adopted a Darwinian viewpoint of how life came to be, and they started even applying it to other things. The survival of the fittest. It just seemed to be a piece of thought that could readily be applied to a lot of areas in the universe that would in some way or another make the need of God unnecessary. You even have people using that in basically dealing with things like particles coming into existence, that the survival of the fittest works in those kinds of levels. It doesn't, and it certainly doesn't work in life, and we'll talk about this here in just a second. In the 1800s, we didn't know about DNA. We didn't know about what actually was happening in cells, how they managed to reproduce themselves, how they managed to have the information that they needed to do that, how they could make an exact copy of themselves, that kind of thing. None of that was known to us. We just did not have the technology as far as electron microscopes and high-powered microscopes, X-ray diffraction, all of those kinds of. We didn't have any of those things back then. In the 1900s, we began to have some of those things, and we started understanding what was going on inside of a cell. In the 1900s, as a result of that, there was something that was called the neosynthesis, or the new synthesis, and Darwinianism, which was survival of the fittest, acting upon random variation. That was what Darwin first came up with. When you get inside of what actually makes things the living things that they are, that doesn't hold up very well, right? Because there's a reason underlying that random variation. What is it? Well, it's got to be the genetic code. So, once we understood the genetic code, it brought in a need to apply that information into that kind of theory. And so they came up with a new synthesis, and now they added the thought of genetic mutation. And so now when you think about Darwinism, what do you think about? You think about survival of the fittest acting upon random mutation. That's the basic mechanism in Darwinism for producing everything. Now, I said that Darwinism fails. It fails, I think, not only in the regard to the genetic code, some of the complexities. That really doesn't affect the mechanism of Darwinism, but something that we've discovered in the last 20, 30 years, not even 30 years really, does, and that is the field of epigenetics. Anyone ever hear about epigenetics? Okay, at least there's one of you. What are epigenetics? Well, maybe you've heard of another expression that may help us here today. How many of you have heard of junk DNA? Right? Now, back in the 80s, it was a watchword. It was something that was almost a mantra with non-believing biology sorts that all that junk DNA proves there couldn't be a creator, because all of that is the leftover detritus of trial and error and things that were tried in the genetic code. It wasn't successful. It wasn't it wasn't working, and so it kind of got left there, appended to the end of the DNA, but useless. And of course, creationists and intelligent designers were saying, no, there's no such thing as junk DNA. This is going to, someplace down the line, we're going to find a purpose and a function for all of this stuff. Well, lo and behold, guess what? We have started finding a function and a purpose for all of those things. What is the function and purpose of those things? Well, it could be a lot more things, but this much we do know, that some of that information is engaged in something called epigenetics, which is regulating how genes get expressed. Now, we all know about genes. Those are the parts of the DNA code that actually are sentences for proteins and enzymes. We call those things genes. So a gene basically has the recipe for a protein or an enzyme or some other biochemical, right? I mean, generally it's proteins and enzymes. But that's what a gene is. And that's, your DNA code is just filled with all those, it's like a big recipe book. It's filled with all the recipes for all those chemicals that your body is trying to produce. And when I say chemicals, I don't mean simple ones. I mean complex biochemicals, carbon chains, polymers, that kind of thing. Anyhow, to get back to the point, what we have discovered, and I say we, I had nothing to do with it, but I'm certainly glad to read about it, right? But nonetheless, what has been discovered is just this, is that genes by themselves don't determine what things look like. Okay? Now, if you've been listening to Darwinism all your life, you've been hearing, right, that a simple mutation in a gene, a simple mutation, it can even be a single point mutation, but a simple mutation in a gene demonstrates the process by which random mutation occurs, and that natural selection can then act upon that random mutation. And if that random mutation provides a survival benefit, then that will get passed on in greater numbers, because those that survive have more kids. It works out that way, right? Those that live end up having more children. Those that die have no children, right? So that's right. That's the basic framework of survival of the fittest, right? If something helps you to live, then it gives you a survival benefit. That survival benefit is going to show itself, reveal itself in the fact that you produce more offspring that are carrying whatever that genetic thing was that caused you to have that advantage. Therefore, over time, right, all these little tiny changes that make these little benefits, they accumulate, and, something that looks like a cow ends up turning into a whale. Isn't that what we've heard? Here's the problem with that. Genes that get mutated are not the basis upon which body plans are brought into existence. Okay? It takes more than genes to determine a body plan. It takes epigenetics. Now, what are epigenetics? Basically, they're networks of genes that are not coding for proteins. These are not part of the useful DNA as opposed to the junk DNA. These are part of the junk DNA. Right? These are not those. They're not the genes coding for those biochemicals. These are just bits and pieces of things that make little machines that affect how genes get expressed. So when you talk about a mutation to a gene producing a change, for instance, in a body plan, a mutation in a gene would not accomplish that. In fact, we have seen that. For instance, one of the things that I know Dr. Michael Behe in the Edge of Evolution demonstrated is that in the laboratory now, we have gone through, I think, like 42,000 generations of E. coli, and we have done all kinds of things to its DNA. After all those generations, and that is more generations than the human race has ever had. But we have gone through enough iterations of, basically reproducing those cells through the genetic means. Guess what we still have after all of that? We still have E. coli. We've gone through generations after generation of of subjecting fruit flies to everything that we could throw at them, including the kitchen sink. After all those generations, what have we demonstrated? In the end, what do you get? You get a fruit fly. Right? You still get a fruit fly. I mean, a more common example, probably not to the depth of generations, would be your pet dog, if you have a pet dog. Now, if you have a mutt, can't say much about that, but if you certainly have a purebred dog, how did that purebred dog get to be a purebred dog? Well, certain animals were picked because of their characteristics by breeders, and they only let the dogs that had those characteristics breed together. You do that over a certain number of generations and you start producing a likeness. Everything that's coming out of those looks the same. So it might look like a boxer, might look like a chihuahua, might look like, whatever it is that it looks like. And we see that and we understand that. Isn't that demonstrating evolution? No. Why? Well, because, a chihuahua can still breed with a St. Bernard. Maybe not naturally. That would be hard, right? that would be quite a work. But at the same point in time, the things that make up that animal, according to its species, are the same. Chihuahua just has different traits than does the St. Bernard. They're not different animals. They are still the same animal. And what that all goes to is just this. It is extremely difficult, it seems, by experience, to change body plans. To actually make something go from one kind of a living thing to another kind of a living thing. It's a really difficult thing to do because mutations aren't capable of producing that. Why don't mutations produce that? They don't produce that because of epigenetics. Genes are regulated by other biochemicals in the cell which determine when certain genes come on, when they get turned off, when they get expressed, and when they don't get expressed. This is very important in the field of embryology, studying how a life form goes from its conception to the place where it's grown into adulthood. In the field of embryology, this is a big part of the study, is exactly what makes genes get expressed. Why are they made to be expressed at certain times in development and then they're turned off, or they're shut down, or in some other way inactivated, and other things go on? Why are body parts kind of like brought into being out of, if you've ever watched a film from embryology about a cell becoming any kind of a creature that it is, it's really quite amazing. Things just kind of like go along and certain little things pop into existence. If you've had gone through a pregnancy in your family and got a chance to take a look at a couple of pictures from the womb, and now they have the 4D images, which are really detailed. But you see, if you see that over time, how unlike a child they start out looking like, and how incredibly things just kind of pop into existence as they age and go through their time of gestation. What is that all about? Well, it's about what we're talking about right now. It's about epigenetics. There are things in our DNA code that serve as a higher level manager, if you will, about how things come into being in a creature that's developed from that DNA as it goes from conception through gestation, or just through the processes of development into the place where it becomes a grown or a mature organism. Here's the thing that's been discovered about those. One guy, this was a computer guy, noticed that he was interested in, when he heard about these gene regulatory networks is what they call these things. But he was interested in, when he came across the information about those things, and he realized that he saw a partial algorithm about how they work to produce what they end up producing. And he realized it looked something similar to what he was familiar with. And so he sat down and actually laid out the algorithms on a flow chart and whatnot, and realized that these things look a whole lot like integrated circuits. You know, a computer guy would see things that way, right? They look like integrated circuits. And these things are not your genes that get mutated that, you know, Darwinians talk about. These things are those higher level epigenetic managers, if you will, of development, and how genes get turned off and turned on in the development of a creature. These integrated circuits, if you will, these higher level epigenetic gene management networks, or gene regulatory networks. If you have a change in your genetic code, a random mutation, you know, there's a good chance that it will never do anything. I mean, you have a very long code. There's only, you know, there's spots in it that a single change can make a difference, but for the most part, a lot of those kinds of things don't make any difference at all. They don't change you, they don't change your biochemistry, they don't change your look, they don't change anything about you really. They're just sitting there, and because your body has ways of dealing with errors in the writing of DNA, the replication of DNA, they do nothing at all. Now that's the whole basis of Darwinian evolution, and it's just a mechanism that doesn't work. But when you talk about gene regulatory networks, those things are super sensitive. You make a change in them and you destroy them for the most part. Very little change is all that's needed to stop development altogether. And so, what are gene regulatory networks responsible for? They're responsible for body plan. They're responsible for development, that you go from you know, a zygote into a mature creature. They're responsible for all of those things. They're responsible for that development. And if they have hardly any change at all in them, it results usually in death. It doesn't produce a better creature, it doesn't produce better information, it produces destruction. Now, Darwinianism could get away with what it was getting away with in the 1800s because we didn't know any better. The neo-Darwinian synthesis in the 1900s could get away with what it got away with because we didn't understand epigenetics and we didn't understand gene regulatory networks. But we're at a point now where I think that we do understand those things, at least with a sufficient clarity to say this: there is no mechanism for Darwinianism to work. There is no mechanism in biochemistry for Darwinianism to work. It's just incapable because of the nature of how we actually work. It's incapable of producing the kind of changes that it purports to give a basis for. So where does that leave you if you are an unbelieving Darwinist? It leaves you in a pickle. Now, you're not seeing, you know, droves of unbelieving Darwinists marching down the road to become believers. I think they ought to be if they looked at the facts. But they can't let it go. Why can't they let it go? Well, sometimes I think it's just because of all of their careers and their development in their careers was based on a certain worldview, a certain perception, and you know, they just can't break out to see things in a different way. That's a possibility. I mean, we do get stuck in ruts, do we not? Right? We do get stuck. We have a way of doing things, and if you've been around for any amount of time doing those things, it's been settled for you. You're not looking for something new. And so I think there's a lot of that, but I also think that there's a lot of this. I am not willing to acknowledge that there's a creator God. I am not willing to acknowledge that there's a God over me. I am not willing to acknowledge that I was knit together in my mother's womb under the watchful eye and by the artful hand of a creator God. But I think that that's exactly the best inference that we can take from the evidences available to us today. For those of you who are involved, engaged in various scientific activities, and whether you're a student or whether you are a professional, you're going to have a tough slog trying to deal with this level of information in your particular field of endeavor. You're going to run into headlong that resistance to change and that unwillingness to acknowledge God, and it's going to be quite a force against you. The headwinds are going to be strong. But in your person, in your personal beliefs, in your personal perspectives, in your worldview that you hold as an individual, what do you need to understand? You need to understand that there is no reason to ever stop believing in the Word of God. There's no reason to stop believing in God as the Creator. There's no reason to stop believing in the words of Christ. There's no reason to abandon your faith for the folly of atheism, for the folly of Darwinism, for the folly of what's being purported by people. And I don't want to say they're stupid. I mean, these are really smart people, incredibly bright and smart people. But what do we know? We know this, that the fear of the Lord is the beginning of wisdom. What else do we know? The fool says in his heart, there is no God. And so even if you have gray matter that will work, synapses that will fire and help you to understand things that are hard to understand and that quite a few people can't, the fact of the matter is that if you're not bowing the knee at the throne of God, you're a fool. And here's the good news for all of us who are willing to be fools along that way. There is nothing in the scientific endeavor that tells us we're fools for believing what we do. Quite the opposite. We've been called fools for a while by folks that were in their ivory towers looking down their nose at us before they had the evidence to back up their case. But now I think we're at a point in time where we can say, you know what? The emperor has no clothes. The emperor doesn't have a mechanism, doesn't have an explanation, doesn't even come close to something that can in any way, shape, or form plausibly develop some kind of a theory as to why something as wonderful as all of you are sitting in this pew. You are fearfully and wonderfully made. You were knit together in the womb by God Himself. And there's not a reason in the world for you to not believe that. And there's not a reason in the world for you to feel bullied, put upon, or made to seem like an idiot by those who don't believe it.